Hello, Anna Mackay here, and this final video in the vector series is proofs using vector geometry. This is going to be one of the theorems here, but let's prove it first. So if M is the midpoint of the line AB, we have to prove that O to M is equal to half of A and half of B. So let's think about what facts that we do know here. We can say that vector OM is equal to, how else could you get from O to M if you can't go along there? You could go from O to A and then from A to M. Let's write that. Now, if we want to get from A to M, we actually want half of the length of A to B. And we can use that fact because it's told us that in the question. M is the midpoint of AB, which means to go from A to M, it's half away along the whole length of AB. So we can write half of AB. Now we can break that down into some vectors that we do know. OA is the vector little letter A, and then we're adding on half of AB. But let's write that with the little letter terms. How do we get from A to B? We have to come along this line here, which is negative A, because we're going in the opposite direction, and then we can add on B. I'm going to rewrite that, putting the negative in the other position. Then I'm going to expand brackets to simplify that, so multiplying through that scalar of a half. I didn't really need to rearrange it this time round. And then collecting like terms. So we've got a whole A and we're subtracting off half of vector A. We're left with 1/2 of vector A plus 1/2 of vector B. And going back and reading what we've got, we needed to prove that OM, as we've got here, is equal to half of vector A and half of vector B. Check, we've done that. Some useful tools in vector proof are some of these theorems. We've just proved the midpoint theorem there. The next one is if you have vector A and it's equal to some scalar of vector B, then two facts about that is that if these vectors are, one is a multiple of the other one, then the only way that that could happen is that if they are parallel. The length, the modulus of these will hold true. To prove that vector A is perpendicular to vector B, we would have to show what? Do you remember from that scalar product? What would that be equal to? If they're perpendicular, it's 0. So that's sort of the shadow that one casts on the other. There is no shadow if they're perpendicular to each other. Some other properties here, I'll just leave you to work through these in your own time. Some dot product facts here and the distribution law. Okay, our second and final proof. Used vector geometry to prove the midpoint theorem. That the line joining the midpoints of two sides of a triangle, start to visualize that, a triangle, that third side is parallel, that joining the midpoints is parallel to the third side and half its length. A picture of that here. So if we were to join the midpoint of two sides, so we've got side here AB, here's our midpoint X, and we join that to the other side, and the midpoint of BC is Y, then that is parallel there to the third side down the bottom here and half its length. And that's the midpoint theorem. So we can't use the facts that they're parallel or anything like that. That's the bit that we have to prove. As we've said here, in triangle ABC, X and Y are the midpoints. So that bit is fact of A and B respectively. Let's label some of these sides with vectors. So vector A here is A to X, and that's also equal to X to B, that vector A there. And therefore on the other side, we would have BY, we'll call that vector B, and being the midpoint, that's the same vector as YC, noticing that the B's used twice. Let's write what we know. Vector XY would be equal to what? So to get from X to Y, how else could I get there? What other path could I travel? I could go from X up to B and then B down to Y. Let's write that. Then adding on BY, and that's equivalent of vector A, and we're adding on vector B. What about the other side? How could I get from A to C? I could go from A all the way up to B and then B all the way down to C. Let's write that. Substituting those with the little letters, so we have two lots of vector A and two lots of vector B. I'm going to factorize out a factor of 2 here. And now you may recognize that what's in the brackets there is also the same as xy. I'll write that out. So we have AC is equal to 2 lots of vector xy, or writing that in terms of xy as the subject, 1/2 of AC. You can't divide by 2, remember, you can multiply by a scalar. So that's the part that we needed to prove. Essentially, that's using this rule that if you have vector A and that's equal to a scalar's worth of vector B, if we go back to our vector properties, if this fact holds true, which it does because we've established the connection between xy and AC, we can summarize this by saying that therefore vector xy is parallel to vector AC, because the only way that they could be scalar multiples of each other is if they're parallel. And the other fact, that the length of xy will be equal to half the length of AC. And then to finish off proof, you technically would write in words where you paraphrase what the question, we've been asked to prove it. Therefore, the line joining the midpoints of 2 sides of a triangle is parallel to the third side and half its length. Thank you for joining me for this series. Subscribe, tell your friends. See you next time.